All right, so this is a word problem here from 6.4, number 11. I've helped a lot of kids, students with this one, so let's go over this. Might be interested in knowing how to do this one. The sum, okay, so there's a few things we need to know what they mean, right? These words, sum. Sum means addition, okay? We're going to add. The sum of the reciprocals, okay? Reciprocals means if you have a 5, the reciprocal of 5 is 1 over 5. If you have the fraction 2/3, the reciprocal is 3 over 2. So it's literally the exchange of the denominator with the numerator. You switch them. Reciprocal. So the sum of the reciprocals of two consecutive integers. There's the third thing we need to know about. Consecutive means one right after the other. Okay? You have one, and then you're talking about the next consecutive one would be the one that's right next to it, right after it. And integers would, of course, be positive or negative whole numbers. So plus 2 plus 3 would be two consecutive integers. Negative 11 and negative 10 would be two consecutive integers. Okay, those would be examples. So we don't know what these integers are, but what we do know about them is that the sum of their reciprocals equals, or is, right here, is 11 over 30. What are the integers? So we need to, first of all, set up a variable or some variables. And again, we're trying to just write the quantities in question, and that is the integers, in just terms of one variable. Okay? So let's say that the first integer is n. Okay? N for number, let's say. So the next consecutive integer would be n plus 1. Now, if you said n and w or something, that's fine. But you're going to want to try and write them in the same, with the same variable, okay? So we want to transform a w, let's say, into something concerning n. So if n is the first number, then n plus 1 would be the next integer. Does that make sense? Okay? So that's the first part, identifying the quantities and letting them be represented by variables or expressions. And then what you want to do is you want to put together an equation, okay? You want to put together an equation. Well, we know that the sum of the reciprocals equals 11 over 30. So the reciprocals of these would be 1 over n. That's the reciprocal of the first one. The reciprocal of the second one is 1 over n plus 1. Okay? 1 over n plus 1. So here we have a rational equation. I want to solve for the one variable that I have in there. No problem. We've done this a ton of times. Now that you have this set up, the rest is probably pretty straightforward, okay? So I understand that the tough part is interpreting the word problem. But if you know the meaning of all of these words, right? And again, this is what we're working on. You need to understand what these words mean. If you don't know what these words mean, you're in serious trouble. So learn them, okay? If you know what those words mean, you can set up an equation, and then you can go back and read the question and see if it matches with the equation that you've made. All right. There's enough preaching for that. But you do need to know those terms, okay? So once you've got this done, now this is easy. We're going to multiply this whole thing by the lowest common multiples of all the denominators. So that's going to be times an n plus 1, and times a 30, okay? So each one, we're going to multiply each term, each of these terms, by these 3 and see what happens. Okay, so 1 over n times this 3, well, the n's would cancel out, wouldn't they? Those would be gone. And I'm left with 1 times n plus 1 times 30. You see that? That's what happens when I do this times these 3. Okay, what's next? Well, I'm going to multiply this one by these 3 next. And so the n plus 1s would cancel out. You see that? Top and bottom. You can cancel out a factor from the top and a factor from the bottom. And so what I'm left with is 1 times n times 30. So 1 times n times 30. Oops, that was a weird 0. It's going to do a bracket. Finally, this term times these 3 give us, well, the 30s cancel out, right? And so we've got equals, don't forget your equal sign here, right? Got to put that equals in there. And so I've got n times n plus 1 times 11. 11 times n plus 1. You with me so far? Does that make sense? Okay. We're just getting rid of the denominators, because without the denominators now, we can simply multiply out these things and gather like terms and then try and solve for n. All right. Oh. So going a little quicker now. This one is like it's not there. So this is 30n plus 30 plus n times 30, or 30n, equals, well, 11n times n plus 1. 11n times n plus 1 is going to be 11n squared plus 11n when you multiply those together, right? So you multiply the first two to get 11n, then you multiply that by the third one to get this. All right, looks good so far? So 30n and 30n, that's going to be 60n. All right. And I'm going to bring now everything over to the right side, so I have a quadratic that I can solve for. So let's see. I'm going to have 0 over here because I'm going to get rid of everything. I'm going to have 11n squared. Now, if I subtract 60n, that's how I get rid of this over on the left side. I need to subtract 60n here. So 11 minus 60n, that's going to be what? Negative 49? Negative 49n. And then minus 30. Okay. You with me? Okay. Do I have that right? Do I have those numbers correct? Those line up with some of you that did this question? Okay. So if you get this and you've done all your addition and your multiplication correct, now we are looking for integers here. So if there are solutions, they're going to be integer solutions. So there's a good chance that I should be able to factor this then, right? Now, is there a common factor I can divide out? Well, 11 doesn't have any factors other than 1 in itself, so I don't think that we can't divide anything out. So can we go ahead and try and factor this? That might be tricky, but maybe not. So the factors of 11n squared would be 11n and n. Now 30 has a number of different factors, so we might have to try a few there, but we got to get to negative 49 when we multiply this out. So what about 6 and 5? 5 and 6. Ooh, 5 and 6. I like 5 and 6 because 5 times 11 is 55. And then 6 minus 6 is 49. That's really good. That's really good. See that? So again, you're going 11 times 5, 55, and 6. The combination of 55 and 6 will get us 49 if we can work the signs correctly. So this has got to be a negative 49. So let's go negative 55, and then we'll add 6 to it. How about that? So that's kind of how you run through some multiplication in your head, and you can do this manually. If you have trouble, again, factoring this, please watch a video or ask questions about how to factor trinomials. This is not the place to learn this. This is just the place to use this. So do some extra work if you need it. But the possible solutions here now, because that equals 0, I let each of these equal 0. So 11n plus 6 equals 0, and n minus 5 equals 0. I get n equals negative 6 over 11 here, and n equals positive 5. The question asks for integers. So guess what? I'm going to reject this one. It's not an integer. Algebraically, we get that as a possible solution to this right here. That's fine. Algebra can give us all the possible solutions it wants, but because we are using algebra, we have to decide which of these solutions might be appropriate for the question. And the question asks for integers. So it looks like n equals 5 is going to be one of my integers. So let's see. If n was 5, then n plus 1 is 6. So I'm looking at 5 and 6 as possible integers. So what I'll want to do is I'll probably want to check that. So 1 over 5 plus 1 over 6 should equal 11 over 30, right? The sum of the reciprocals of two consecutive integers equals 11 over 30. So I just want to check this. And of course, if I got a common denominator here, I'd multiply top and bottom by 6. Over here, top and bottom by 5. I would get 6 plus 5 over 30 equals 11 over 30. And boom, right away, you see that we've got a winner. Okay? So that checks out. So 5 and 6 are your numbers there. All right, so that's how you use a rational equation to solve a real world problem. And believe it or not, this is going to be very useful coming to calculus, right? Remember, we're in a pre-calculus class. So pre-calculus 20 is leading towards what? What do you think this is leading towards? Yeah, calculus, right? So in calculus, you need to know how to do this. There are going to be some calculus methods in here that you're going to use in grade 12, right? When you do calculus. In here, we're going to use some calculus. We're going to do some calculus stuff. But the root of this question right here is preparing you for calculus. So good job. Any questions? Guys get that? Okay. All right. Good job.